This problem is based on parallel connection of synchronous motors, and this was appeared in 2017 in session 1 for 2 marks. Now we will see what the problem is saying and how to solve it. So first of all, it is saying two parallel connected three-phase 50 Hz 11 kV star connected. Star connected synchronous machines A and B are operating as synchronous condensers. They are operating at synchronous condensers. They together supply 50 MVAR to a 11 kV grid. Whenever something is some machines are working as a condenser, means they will provide some reactive power, right? To supply reactive power, they will we work motors or generators as condensers. Now, current supplied synchronous condensers is nothing but let us synchronous condenser is nothing but an overexcited motors whose work is to supply the reactive power either to grid or load. So here also they are supplying 50 MVAR to a 11 kV grid. They are generally motor take the power from grid or supply, but here they are working as a condensers and they are supplying reactive power to a 11 kV grid. Now, current supplied by both the machines are equal. So see, I1 and I2. Two currents will be supplied by two parallel connected condensers and both currents are same. So I1 is equal to I2. Now, synchronous reactances of machine A and machine B are 1 ohm and 3 ohm. Reactances are given and both are different reactances. Now, if reactances are different, means we have we will achieve different excitation EMF or EF field EMF. Now, assuming the magnetic circuit to be linear, we do not have to consider the saturation of the motor or core. We have to calculate the ratio of excitation current of machine A to the machine B. Means we are asked to find the excitation current ratio of machine A to machine B, which would be proportional to EFA by EFB. If we find EFA and if EFB, the ratio of both would give us the answer. So let us see how to approach to this kind of problems. Now, we know from the problem that I1 and I2 are equal. Now, total current which would be supplied to the grid, that would be I1 plus I2. Now, we know reactive power. If reactive power is given, we can calculate the current, total current, that is IL. IL. 50 MVAR is given. If 50 MVAR is the load, then the current, whatever would be there, it would be lagging since we are dealing in terms of reactive power. And that is also, it is supplied, and whatever supply, it is acting as condensers, and to the load it will be lagging current. So whenever any machines, condensers, capacitors, they are supplying lagging power. Okay, they are they absorb leading power, capacitors or condensers, but they supply lagging power. That is the property of condenser. Now, the current which would be supplied to the grid, that would be calculated, and you is equal to root 3 VL IL, right? So I have written this formula and I have solved to calculate this IL, and IL turns out to be 2624.32 ampere. Now this would be minus 90, right? Because it would be lagging current as I told you. Now in problem it is given I1 and I2 are equal and it would be half of the total current. So total current would be 1312.16 lagging by 90 degree. Okay, perfect. Now we have to calculate E1 or EFA, let's say. So to calculate EFA, the terminal voltages are same, that is 11 kV. We just have to apply a KVL in the loop. So let's say uh, VT is there. Now EF is equal to VT minus AIA XS. This is the KVL in motor. From DC machine also you can recall that. No issue. So EFB, let us say. Now after doing all or after solving this equation, because we know IA or I1, whatever you want to say, and XS1 is also given 1 ohm. So here EF1 would be 7662.85, that is phase value. Whenever we apply KVL, try to make all the terms in phase value. Okay, otherwise it would be a huge confusion. Now for EF2, EF2 would be also same, VT minus JIA2 XS, and here XS is 3 ohm, but IA2 is same. So here overall EF2 turns out to be 10,286.85 volt. This is also perfect. Now we discussed that IF1 by IF2 will be the ratio of EF1 by EF2, and that is nothing but the 7662.85 divided by 10,286.85, and that would turn out to be 0.745, and this was the answer provided by IIT Roorkee. Thanks.